So we have a small experiment to show or demonstrate self-induction. Quite simple. We have a source of battery, a rheostat and a key. And by the way, there are many such experiments. You guys can write or find whatever you find comfortable. Please write that in your exam. So we have a bulb, we have a coil. Now, coil and a bulb. The procedure is quite simple. You switch on the key, and then when releasing it, observe the bulb. That's it. That's your procedure. Please note that the self-induction aspect can be observed even when you switch on and when you switch off. So I'm just doing this part when you switch off. You guys can have a look at this also. This is also quite interesting. This is easy, that's why I took it up. Now when you release it, what do you observe? When the tab key is released, the bulb glows brightly for a moment and then goes off. The reason is quite simple. Initially, when you have the bulb, not the bulb, sorry, the current flowing in this way, what happens? There is a magnetic field that is produced within this, right? It will slowly build up. Once it's built up, there is then continuous flow of current and all of that. When you release it, it will try to oppose. How? By making it continue the current or making the current flow in the same direction, it will try to do so. How will it do that? By setting up a voltage in this direction. This is your Lenz's law EMF. Again, this is a case wherein we have switches off. You have to be very specific. So it will try to maintain that current by inducing a voltage in this direction. So the current will continue to move in this direction because initially it was in this manner, right? It'll try to oppose that change, that is change of it being switched off. For that to happen, it will induce a current in this direction. For that to happen, it needs to have a voltage in this direction. So all in all, this is how you should understand this. Okay, so the write-up is over here. So let's read through and revise. So explanation, magnetic flux. When the circuit is completed, current flows through the solenoid, creating a magnetic field and linking magnetic flux with the coil. Makes sense. Self-induced EMF, right? So initially, this is what is going to happen with the coil. Now, when we release the switch, let's see what happens. When we break the circuit, the magnetic flux linked with the coil suddenly vanishes. This rapid change in magnetic flux induces a large electromotive force, the voltage in the coil, known as self-induced EMF. Okay, guys. So one last perspective. You guys want to write this or not in your exam? That's left to you, but I want to put it across. So in which two places are we looking at sudden change in voltage in the circuit, right? First and second. So in both of this case, we get to see change in voltage, sudden drop or increase in voltage, right? So there is a sudden drop over here, sudden increase over here. We are just looking at the second case. Here too, in the first case, the coil will have a opposing voltage and slowly it will reduce and allowing a lot of current to flow through it. It will act as if there is nothing over there. So this will continue. At this point wherein there is switching off, what happens? There is a sudden change in voltage. So this leads to sudden change in flux. This leads to magnetic field stuff, and we have induced voltage over there. And this voltage will be reverse, and in time it will vanish. So during this time is where the bulb will glow bright. Does it make sense? There's a huge voltage change. So there is a huge change in flux. Then so there is the magnetic field also changes drastically. And so we have a induced EMF which is very high. Does it make sense? That's just another perspective. So finally, to conclude, the experiment demonstrates the principle of self-induction where a changing magnetic flux induces a EMF in the same coil, opposing the change in current. This is why the bulb glows brightly momentarily when the circuit is broken. Again, this part of the graph, the graph part of the answer is left to you guys during exam. If you write that, it shows maturity and understanding of the topic.